In this video, we're talking about how to factor the sum of two cubes. We've got a couple examples here. The first one is 8m cubed y to the sixth plus x cubed. Notice we have a sum because we have an addition sign in between these two terms. And notice that both of the terms are perfect cubes. 8m cubed y to the sixth is the perfect cube of 2m y squared, because if we take the cube root of all three of these individually, the cube root of 8 is 2, because 2 times 2 times 2 is 8. The cube root of m cubed is m, because m times m times m is m cubed. And the cube root of y to the sixth is y squared, because y squared times y squared times y squared is y to the sixth. So what we're dealing with is the sum of two perfect cubes, and sometimes we need to factor the sum of two cubes, and there's a specific formula we're going to follow, or a pattern that we're going to follow in order to factor the sum of two cubes. The first thing we want to do is draw two parentheses like this. We're going to have an addition sign in the middle, always. Remember, this is a pattern, so you're always going to be able to follow the same process. We're going to take the cube root of each of our terms. Remember, we said the cube root of 8 was 2, the cube root of m cubed was m, and the cube root of y to the sixth was y squared. So we're going to have 2m y squared plus now the cube root of x cubed, which we know is x. So that's the first part of our formula. We take the cube root of all of these terms, we always have an addition sign in the middle, and that's our first binomial. Then we're going to multiply that by a trinomial. In other words, there's going to be three terms in this polynomial. The first term is going to be whatever we have to multiply this by to get this. So in other words, what do we have to multiply by 2 to get 8? Well, that's 4. What do we have to multiply by m to get m cubed? M squared. And what do we have to multiply by y squared to get y to the sixth? Well, that's y to the fourth. So that's our first term. Then we always have a minus sign. This is always going to be subtraction. Whatever we get when we multiply this term by this term. So we just multiply the whole thing together. 2my squared times x is 2my squared x. And the last term, this is always going to be addition here. The last term is going to be the square of whatever this term is here. So x squared is of course just going to be x squared, and then we close our parentheses, and this is the pattern we use every time to factor the sum of two cubes. So using this same process, let's try to factor the sum of these cubes, a cubed plus 27b to the sixth. So first of all, we want to confirm we have a sum, and we do because we have an addition sign here. And then we need to confirm that both of these are cubes. A cubed is the perfect cube of a, 27 is the perfect cube of 3, and b to the sixth is the perfect cube of b squared. So we definitely have the sum of two cubes. So the first thing we want to do is draw our parentheses for this first term that we had here. We're going to take the cube root of a cubed and get a. Then we're always going to add. Then we're going to take the cube root of 27b to the sixth, which is going to be 3b squared, because the cube root of 27 is 3, and the cube root of b to the sixth is b squared. Then we're going to multiply that by our trinomial, so we're going to multiply that by the trinomial here. And remember, what do we have to multiply by a in order to get a cubed? That's a squared, so that's the first term. Then we always subtract, so we subtract here. And now we're going to multiply both of these two terms together. So a times 3b squared is 3ab squared. And then we always add, so we're going to add, and we're going to take the square of our last term. So 3b squared, when we square that whole thing, we get 9b to the fourth. And we're done with our factoring. As always, if we want to check to make sure that we did it right, we can FOIL this back out. So what we can do here with the second problem, we'll do an example. We'll take the first term in the binomial and multiply it by each of these three terms in our trinomial. So a times a squared is going to give us a cubed. A times negative 3ab squared gives us a negative 3a squared b squared. A times 9b to the fourth gives us plus 9ab to the fourth. Then we're going to take 3b squared and multiply it by each of the terms in the trinomial. So 3b squared times a squared gives us 3a squared b squared. 3b squared times a negative 3ab squared gives us a negative 9ab to the fourth. And 3b squared times 9b to the fourth gives us 27b to the sixth. Now we want to go ahead and combine like terms, so we're going to have this a cubed by itself. We can't combine that with anything else because there's no other terms here that have just a cubed, so we're done with that one. We have a negative 3a squared b squared and a positive 3a squared b squared. Those together will equal 0. Then we have a 9ab to the fourth and a negative 9ab to the fourth. Those will combine to be 0. And then we just have plus 27b to the sixth. And as you can see, we ended up with our original problem, so we know we did our factoring correctly. And that's how you factor the sum of two cubes.